Okay. So we start uh, this integration by parts. So we are not going into the derivation of integration by parts as it is not required right now. So we will come to the result and its application. If you have two functions, u and v, multiplied to each other, and you are integrating. So you can do like this, that the first function integration of another one minus there is a big integration, and there is inside this derivative of the first function into integration of the second function. This is something like this. I will give you an example here, and there will be some rules also which we have to follow. So it is x sine x dx. There are two functions. One is x, another is sine x, and they are multiplied to each other. So if we'll apply the above formula, we'll say x integral of sine x minus integration, and inside this integration, derivative of first function, which is x only, into integration of the second function, which is sine x. Can you understand this? Okay. Now, what is integration of sine x? It is minus cos x. So we'll write it like this. And here dx by dx is 1, and integration of sine x is minus cos x, as cos x derivative is minus sine x. So we get minus x cos x, and then this minus come outside, so plus integration of cos x. So it will become minus x cos x, and integration of cos x will be sine x plus c. So this will be your answer. So you can note this down. Now we'll see what happens if we interchange them. Have you noted it down?
Yes, sir.
Okay. So if suppose we take sine x as the first function and the x as the second function, because it is not specified which is first, which is second. So by some may take x as first, some may take sine x as first. So what will happen in that case? So first function into integration of second function minus big integration, differentiation of first function, and integration of second function. So this will be sine x into integration of x is x square by 2. And here derivative of sine x will be cos x. And integration of x will be x square by 2. So this is x square sine x by 2 minus 1 by 2 outside x square cos x. Now situation has got worse, because earlier it was trigonometric into x, now it is quadratic into cos x, not x square. Then you have to integrate that. So here you can't keep on doing like this. So this will never end. So it is important to choose the first function or the second function wisely. If we take them in different order, we may not be able to solve it. So what is the order which we have to satisfy? So here we can't do it further. In previous one, you can see you vanished sx as its derivative was 1, and then you got the cos x integration. But if you change the order, you may land in problem. Are you realizing this?
Yes.
Okay. So there is a rule called ILATE. Most of the cases, this rule is applicable. In some exceptional cases, you may have to do something else, but generally you have to apply this rule. So I stands for inverse trigonometric function. L stands for logarithmic function. A stands for algebraic function. T stands for trigonometric function. And E stands for exponential function. So you know all these type of function: inverse trigonometry, sine inverse, cos inverse, tan inverse, all those functions. Then logarithmic function is log x. Algebraic is this x square, x cube, and its other power, x power. And polynomial function, root over x square plus 2, root over x plus 3, all these. Trigonometric, sine x, cos x, tan x. Exponential, e to the power x or a to the power x. So this order we have to follow in order to take u and v. For example, above one, we took x and sine x. So if you observe, what is x? X is an algebraic function. And what is sine x? It is a trigonometric function. So in this islet, which comes first, a or t? So a comes first, which is algebraic. So you will take a as u and sine x as v. Then you will be able to solve it. That is what we have done above. If we took it otherwise, we got a problem. Is it okay?
Yes, sir.
No, you haven't understood this?
Oh, no, sir, understood.
Okay. So you can note it down.
Done.
Done. Okay. So if you now see few questions. .6 exercise. I will also tell you one more rule, but let us first do few questions based on what we have done till now. Six, 8, and 10. Try these three questions first. Yes, Darnell. Question number 6 done.
Oh, yes, I'm in the one right now.
Sorry,
Yes, I'm on the eighth one.
eighth one. Okay. Darnell, what is the answer for sixth one that you have got?
Oh, so I got x cubed log x by 3
Okay.
minus x cubed by 9 plus c.
X cubed by 9 plus c. So isolate, this is u, this is v, first function, integral of second, as integral derivative of first, integral of second. So this will become x cubed by 9. Correct. Eighth one, how are you approaching?
Oh, so the eighth I got the answer. X squared by 2 tan inverse x
Yes.
minus x by 2 plus half tan inverse x plus c.
Okay. How have you started it?
I took tan inverse x as u and x as v.
Okay. Tan inverse x as u and x as v. Fine. So after doing this, you get first function integral of this correct minus an integral derivative of this 1 by 1 plus x square into integral of this dx, and then you integrated this x square plus 1. So that will become half x, that is also fine, and minus 1, so half, and tan inverse x. Okay, that is also fine. Perfect. 10th one, that is little tricky.
So I'm not sure how to do the 10th one.
Sorry.
I'm not sure how to do the 10th one.
So I will give you a hint. Sine inverse x whole square is there, and there is no other function. So this is actually sine inverse x. What you do first is do one thing. तो यहाँ पे do one thing. Let sine inverse x is equal to theta. That is x is equal to sine theta. Dx is equal to cos theta d theta. And change the function in this form, that sine inverse x whole square is theta square and dx is cos theta d theta. Then proceed. So this is how now you proceed. And when you get the answer, you can write theta as sine inverse x again.
So for the 10th one, I got theta square sine theta
Theta square sine theta. Okay, 1 second.
minus
Minus.
2
Yeah.
whole bracket minus theta cos theta
Minus theta cos theta.
plus sine theta plus c.
Sine theta plus. Okay. So you applied by parts 2 times, right? The first function
Yes.
minus integral derivative. Derivative is the 2 theta into integral will be sine theta. And then you wrote it as minus 2. And then again you applied first function into integral of this minus cos theta minus integral derivative. And this will be cos theta d theta, which will be sine theta. So sine theta and minus theta cos, right? And in the end, you have to do this thing that theta is sine inverse x. So sine inverse x whole square and sine theta is x. Here it will become plus 2 theta. So 2 sine inverse x into cos theta, which will be 1 minus x square as 1 minus sine square theta minus 2 sine theta. That will be x plus c. So this is what you will get. Is it okay?
So please can you explain it again?
Theta is sine inverse x, sine theta is x, cos theta is root over 1 minus sine square theta, that is 1 minus x square. So you have to substitute these things wherever it is to be substituted.
Right. So how did cos theta change to root of 1 minus x square?
Because cos theta is equal to root over 1 minus sine square theta.
Yes.
As cos square theta plus sine square theta is equal to 1. So this will be 1 minus x square.
So can't we just leave it as cos theta?
Sorry?
Can't we just leave it as cos theta?
No. Question is in terms of x, no? It is not in terms of theta. So you have to give the answer in terms of x.
Good answer.
Okay. Now, another way to approach the same question is, this is sine inverse of x ka whole square dx, is you can take sine inverse x whole square into 1 dx. 1 is always multiplied to anything. So you can take this as the first function, this as the second function. And I'm not doing the whole step because by substitution we have already done. I'm just telling you a way through which also you can do this. The first function, integral of 1 is x minus integral. Derivative of sine inverse x whole square will be 2 sine inverse x. And derivative of sine inverse x by chain rule is 1 by root over 1 minus x square into integral of x dx. Now further you can apply the chain rule again. So this will take some time, but it will also can be done, but it will be a little difficult to analyze in between that how you have to do by parts. But this is a method. Another question could be integral of log x dx. Now here again, you have only one function log x. How can you apply by parts? And there is no other way through which you can do this. So you can take log x into 1 dx. 1 can be helpful in such cases. In above case also it is helpful. here also. So here you can, if apply isolate, so L comes first and algebraic comes later. This one is algebraic, one is x to the power 0. It is algebraic. So first function, integral of 1, which is x, minus integral, derivative of log is 1 by x, integral of 1 is x dx. So this will cancel and you will get x log x here, minus integral of 1 is x plus c. So this will be your answer. So this is another way which will be helpful sometime to you to solve those questions through by parts where only one function is given. You can take another function as 1. Is it okay?
Yes.
You can note it down.
Good answer.
Okay. Now, one more thing which is important here, and if you see questions from 16 onwards, so most of the questions are based on a concept that e to the power x fx plus f dash x dx integral is equal to e to the power x fx plus c. So if you do the integration of this, how you get e to the power x fx plus c? This is a type of formula which we directly apply. Like if it is suppose e to the power x log of x plus 1 by x dx. So log of x is a fx and f dash x, its derivative is 1 by x. So this answer will be e to the power x log x plus c. We can directly say. But why is it so in general? So if we see this e to the power x fx plus f dash x dx situation, you can write it as e to the power x fx dx plus e to the power x f dash x dx separately. And first one, let us not disturb e to the power x fx, we leave it as it is. The second one, what am I doing? I'm taking it as a product of two functions and applying by parts. This is u, this is v. So first function into integral of f dash x. So f dash x is the derivative of fx. So its integral will be fx minus integral derivative of e to the power x. That will be e to the power x. And integral of f dash x will be fx. Can we write it like this?
Yes.
Okay. Now after doing this, this first term and this last term is same, which are of opposite sign, they will cancel. And you'll get e to the power x fx plus c as your answer, constant of integration. So you can directly say that in such situation, you don't have to show these steps. You can write it like this. So if you apply this on few questions, like you can apply this in the question number, you have to do some arrangement also. So let me tell you which question you should do. 17 and 18. Question 17 and 18, you just try from this exercise. I'll be back in 2-3 minutes. You just try these two questions.
Yes.
Yes, Darnell. Have you any doubt in 17th?
Oh, so I got EX by 1 plus X plus C.
Okay. So you have written x as 1 plus x minus 1, right?
Oh, yes.
Okay, then you got e to the power x into 1 by 1 plus x minus 1 by 1 plus x whole square. So this is the derivative of 1 by 1 plus x. So yeah, correct.
So I'm not sure to do the 18th one.
Yes, Darnell.
Oh, so I'm not sure for the 18th one.
Okay. So it is e to the power x 1 plus sine x by 1 plus cos x. How are you trying to do this? So let me explain it to you. What you can do here is uh, you change it into tan x by 2. So what you can do, you can change sin x as 2 tan x by 2 by 1 plus tan square x by 2. Most probably this we can do here. And cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2. So what you get is 1 plus 2 tan x by 2 by 1 plus tan square x by 2 by 1 plus 1 minus tan square x by 2 by 1 plus tan square x by 2 dx. This you can write it. Next step, you take the LCM in the numerator and denominator. It will be 1 plus tan square x by 2 plus 2 tan x by 2. And in the denominator, 1 plus tan square x by 2 plus 1 minus tan square x by 2. And 1 plus tan square x by 2 from the numerator and denominator will be cancelled, which is the LCM of them. So e to the power x numerator will be 1 plus tan x by 2 whole square, or it is better to write it as, instead of this, 1 plus tan square x by 2 as sec square x by 2, and leave 2 tan x by 2 as it is. And in the denominator, tan square x by 2 will cancel, 1 plus 1 will be 2. So after doing this step, what you can do, you can divide by 2. So this will be half sec square x by 2 plus tan x by 2, as 2 will cancel dx. So finally, can you write it like this?
Yes.
Now this tan x by 2, if taken as fx, then its derivative is sec square x by 2 into half. That is the coefficient of x by linear extension. This will be f dash x. Tan x is sec square x. So tan x by 2 is sec square x by 2 into half. That is the coefficient of x, which is half, will be multiplied. So the final answer will be e to the power x tan x by 2 plus. So why we have thought like this? Because sin x and cos x are not making any combination. So we thought suppose if we take both in the same terms, that is tan x by 2, so we can do this. So most of the cases when we try to make them into the same term, we do this tan x by 2.
Don't.
Okay. Now we see integrals of some more types, which is the next exercise. And in indefinite integration, this is the last exercise. Then we have definite integration, which have 1, 2 exercises. One is based on substitution, one is based on that properties. So indefinite integration, last 3 formula, which is important. This is exercise 7.7 theory. So it says that integral of root over x square minus a square dx. Second one is root over x square plus a square dx. And last one is root over a square minus x square dx. These 3 formula we have to remember. We will derive one of them and then we will try to remember all the 3. So any one formula, which one you want to derive?
So do the first one.
First one, root over x square minus a square. Okay. So root over x square minus a square dx. You have to find integral. Let us suppose this is I. So first of all, we are studying this after by parts. So by parts has an important application in this. So what you will do, what you will take it is root x square minus a square into 1 dx. Now important thing here is that both of these are algebraic function. You have taken one as the another function, but that is also algebraic function. First one is also algebraic. It is neither trigonometric, nor inverse trigonometric, nor logarithmic, nor exponential. It is algebraic. So which is u, which is v. So in such situation, if both is same type of function, we take v, which is more easily integrable, because integration is difficult. Differentiation is not difficult. So here one is more easily integrable because its integration is x. Root over x square minus a square integration is the question itself. So it is already difficult. So we will take it as v and this as u. I will write root over x square minus a square into integral of 1 x minus integral derivative of u. So that will become 1 by 2 root over x square minus a square into 2x by chain rule into x dx. We write it like this. Can we write it like this?
Yes, sir.
Okay. So in the next step, we write it root over x square minus a square into x minus 2 cancel x square by root over x square minus a square. And then what we do is we do minus a square and plus a square dx. And then we write it as x root over x square minus a square. And when we separate this, so it will be integral of root over x square minus a square in the numerator, which will remain. And then minus a square integral of dx by root over x square minus a square. This is what we will get. Now, important part here is this second one is nothing but I. This is what we started finding out, root over x square minus a square integral. So this is I. And this another one is the formula which we studied in one of the previous exercises, log of mod of x plus root over x square minus a square plus c. So this is what we are getting. So I, if we take on the left, so I plus I will be 2i. 2i is equal to x root over x square minus a square log of mod of x plus root over x square minus a square plus c. So I, which we have to find out, is x by 2. 1 second. X by 2 root over x square minus a square by 2 log of mod of x plus root over x square minus a square plus c. So this is the formula for integral of root over x square minus a square dx. So this is the first formula which we have to remember. Do you want to note it? Have you noted it?
Oh, yes.
Understood all the steps?
Yes.
Yes.
So could you show how you differentiated root of x square minus a square?
Okay. So root over x square minus a square will be differentiated. This would be 1 by 2. So 1 by 2 and x square minus a square to the power minus 1 by 2 it will become. It will come in the denominator. And then x square when differentiated will be 2x. A square will be 0. So this is what we will get. Okay.
Oh, yes, sir.
These steps below, do you want to note it down or you have noted it?
Also done.
So if we try to remember the three formula which are involved here, it is not so difficult. So they seem to be lengthy, but it is not difficult. If we see a pattern here, what is the pattern? Let me show you. These three formula you have to remember. And they are arrangement of a square x square plus minus. So you have to take two terms. And in those two terms, first is x by 2 here, x by 2 here, x by 2 here. Another one term is starting with minus a square by 2. If it is minus a square, then minus a square by 2. If it is plus a square, then plus a square by 2. And here also plus a square, so plus a square by 2. Is it okay?
Yes.
And then this part will be root over x square minus a square as it is the question one. Root over x square plus a square as it is the question part. Root over a square minus x square as it is the question part. And then the second part will be multiplied. So if you remember that root over x square minus a square, if it was in the denominator, we studied this formula earlier, then its integration was log of mod of x plus root over x square minus a square. So that formula will be applied. So if you remember that formula here also, you can put that. Second one, the formula was log of mod of x plus root over x square plus a square. And third one, the formula was sine inverse x by a plus c. Is it okay?
Yes.
So these three formula you can remember like this. So let us do few questions from this exercise, which is 7.7. The completing the square concept you have to apply here also, as we were applying in the previous exercises. So three questions I want to do. I want you to do and try to do complete them, because this is the nutshell of what we have been doing. So it is a mixture of many exercises. Last exercise of indefinite. So this is 3, 7, not 7. Let us do, yeah, 7, fine. And 11, these three. Yes, Darnell, are you doing this?
Oh, yes.
Okay. Third one, have you got the answer, Darnell?
Oh, yes.
Okay, tell me. First, I will note it down, then I will check.
Oh, 1 second. Oh, so the third one is x plus 2 by 2,
X plus 2 by 2, fine.
whole root of 2 plus x square plus 4x plus 4.
2 plus x square.
Yes, sir. 2 plus x square
Okay.
plus 4x plus 4. No, so like 2 plus x squares and the normal 2 plus x square.
Okay, okay. 2 plus x square, fine. So it is 2 plus x square. Okay.
Plus 4x plus 4.
Plus 4x plus 4. So can't you write it like this? X plus 2 by 2 into root over x square plus 4x plus 6.
Oh, yes.
Question itself. Okay, then
Uh, plus log mod of x plus 2 plus root of x square plus 4x plus 6.
okay.
Mod c plus c.
And multiplied with something before log.
No, so nothing.
Oh,
So
a
it's
square by 2 will
root,
be 2 by 2. That will be 1. Fine. Perfect. So you have got the correct answer for the third one. Today is 2-hour class, no?
oh, yes. So for the seventh one, so I got 2x minus 3 by 4.
One second. This will become 1 plus 3x minus x square will become 1 second. 1 plus 3 by 2x minus x square into 2. So it will become 1 minus 9 by 4 plus 9 by 4 and plus 2 into 3 by 2x minus x square. So this will combine and this will be 13 by 4 minus x minus 3 by 2 whole square under root x square minus plus 3x fine and then minus 9 by 4. First of all, tell me, are you getting this? First, you are simplifying. Yes, Darnell, are you getting this?
Yes.
Like this you are getting, now?
Yes.
That is root over 13 by 2 whole square minus x minus 3 by 2 whole square. Yeah, now you can tell me.
Oh, so 2x minus 3 by 4.
2x minus 3 by 4, perfect.
Whole root of 1 minus x square plus 3x.
1 minus x square plus 3x
Plus 13 by 8.
plus 13 by 8, okay.
Sine inverse 2x
Sine,
minus 3 by root 13 plus c.
okay, fine. Perfect. Next is question number 11, last one.
Oh, so I'm supposed to do the ninth question, sir, or 10th?
11th, last one.
11, okay. So for the 11th one, x minus 4 by 2.
1 second, let me see the question. So 11th one, when you will do, it will become 16. So minus 9. So x minus 4 whole square. And then you will have 3 square. Okay, so which option are you getting?
So option D.
Option D.
Yes.
Okay, seems fine. X minus 4 by 2 into this minus a square by 2 it will become definitely. So no, it will be minus 9 plus 9 plus minus a square by 2 log of this plus this. Yeah, correct answer you're getting. D, option D is your correct answer. Now we have done from NCRT. I'm not starting definite integration today. Instead of that, now out of all the exercises till 7th exercise, what we have done in indefinite integration. This we have completed indefinite integration. I will give you few questions which are of mixed nature and little bit of higher level than NCRT. And I'll see that how would you perform in those questions. Is it okay?
Yes.
So one question is integral of log of x minus 1 by 1 plus log of x whole square, and this is log of x minus 1, and further whole square of this. Okay, so log of x minus 1 by 1 plus log of x square and whole square of all of this. So this is the first question, and I'm giving you the option also that so that you will be able to think that which direction would be right. So A option is you may have to use substitution also and some more thing also. Log x by log x whole square plus 1 plus c. This is A option. Another one is x by x square plus 1 plus c. Another one is x e to the power x by 1 plus x square plus c. And another one is x by log x whole square plus 1 plus c. Another question which we have is right now, if uh, if let us forget about if, or let us say if integral of 5 tan x by tan x minus 2, 5 tan x by tan x minus 2 dx is equal to x plus a log of sin x minus 2 cos x mod. So this right hand side is given to you except a, so that it will be used as a hint. Then a is equal to question mark. What is a? Options are minus 1, minus 2, 1 and 2. First try these two questions. Generally, taking log and solving this sometimes is a bit difficult. So first you can suppose that log x is equal to t and do all the substitutions according to that.
So if log x is equal to t, then what will ex be?
What will be x? First, what will be x? If you are taking log x as t, what will be x? We are stuck at simple things. How log is changed? E to the power t, isn't it?
Is it e, sir?
Sorry. Log x is t, then x is e to the power t, isn't it so?
How is it e, sir? How did log inverse change to e?
This is what is the definition of log and exponential, that if we have log of b to the base a is equal to c, this means that a to the power c is equal to b. That is how the birth of log has happened. So if it is log of x is equal to t, something is not written, then it means e is there. If log of x is equal to t is there, this means base is e, nothing written. So e to the power t is equal to x.
Okay, sir.
So in that case, e to the power t dt will be dx. Dx will be e to the power t dt.
So for the first one, it's option D.
Option D. Okay, so let's see how you have done it. So can you tell me the steps which you have followed? First step.
Log x is equal to t, x is equal to et, and dx is et dt.
Okay.
And then I substituted, and then after that you get the EFX formula, the EFX
Yeah,
plus F
what is
dash
the first step that you are getting after substitution?
t minus 1 by 1 plus t square whole square et dt.
Okay, whole square is
Whole square et dt.
let me see log x minus 1 by 1 plus log x. Yeah. Then what is the next step that you have done?
Or t square minus 2t plus 1 by 1 plus t square whole square et dt.
Perfect.
Then I took t square plus 1 and minus 2t as
Separate.
two separate.
Perfect. Okay. Then finally, what you got the answer as?
Then I got et 1 by t square plus 1 plus c.
Et by 1 plus t square plus c. That is it.
Yes.
Okay. This will become log of, this will become x by 1 plus log of x का whole square plus c. So option D is x by, yeah, perfect. Now let us come to second one. Okay.
So how do you do this question?
Here I will advise you first change tan x into sin x by cos x and then proceed. No substitution first. First write tan x as sin x by cos x, simplify and think something. If you will not be able to do after that, then I will again suggest you something.
So after you do the sine and cos part, how do you proceed?
Yeah, let me explain it. So 5 tan x by tan x minus 2 it is. It will be equal to 5 sin x by cos x by sin x by cos x minus 2 dx. It will be 5 sin x by sin x minus 2 cos x. Yes, have you got this?
Yes.
One very important thing is there. As we studied the concept of partial fraction, in a similar manner, not similar manner, but resembling that, there is a method which we can apply here. What is that method here? So numerator is 5 sin x. I want it to write it as a times sin x minus 2 cos x, which is the denominator, plus b times derivative of the denominator. So this denominator has derivative cos x plus 2 sin x. Have you understood this part? That I have divided 5 sin x as one part, which is the denominator, and another part, which is the derivative of denominator. Now we don't know what is a and b, capital A and B. But can we find such
So please can you
capital
explain this
A?
step again?
Sorry. Hello. Is it okay? Are you there, Darnell?
No, yes, so sorry, my laptop died.
Okay. So what we are talking about here, is this clear? This is step which we were talking about is clear. Can we write 5 sin x, which is the numerator, as a combination of linear combination of denominator and its derivative?
Oh, so but how?
That is to find a and b, how we find a and b. But can we express it like this for some a and b if we can find out? Like we write it as 5 sin x, and this will be a sin x, and from here 2b sin x. So a plus 2b sin x. And if we talk about cos x, then it is b cos x minus 2a cos x. Now, if you equate the trigonometric functions coefficient, so sin x coefficient is 5, and here it is a plus 2b, and cos x coefficient is 0, here it is b minus 2. So if you solve these two, 2a will be equal to b. So if you solve this 2, b is equal to 2a, 5a, a is equal to 1. And if a is equal to 1, b is equal to 2. So you can write 5 sin x as sin x minus 2 cos x, as a is 1, and b is 2, 2 times of cos x plus 2 sin x. You can check also, if you simplify this right hand side, will you get the left hand side?
Yes.
Okay. So I write this question like this, that it is integral of 5 sin x, which is sin x minus 2 cos x, plus 2 times of cos x plus 2 sin x, by denominator, and denominator was sin x minus 2 cos x dx. Now this and this will be separately written, and it will be 1. Its integration will be x. And another one plus 2. And as you can see that this part is the derivative of this. That is what we took it. So if you take denominator as u, the numerator will be du. That is, the integration will be log of mod u, which is sin x minus 2 cos x, and then plus c. This will be your answer. So a is equal to 2. They gave that find a. Rest they gave already, that you can be used as hint here in this question. They gave that it will come out to be x plus a log sin x minus 2 cos x by k. So what is a? A is equal to 2. So you can write it here. Have you understood this?
So I didn't understand how you like split 5 sin x to the denominator plus 2 times the denominator derivative.
So I have done this thing, that I have supposed that 5 sin x is a times this denominator plus b times its derivative. Now, can we find such a and b? So what we have done, we have equated the coefficients of sin x and cos x both the side and found a and b. Now, if you put a and b there, you get 1 into this plus 2 into this. If you simplify this, 1 sin x plus 4 sin x, you'll get 5 sin x, and minus 2 cos x and plus 2 cos x here, you will get 0 cos x. So you get this as 5 sin x, which means you can write 5 sin x like this. There is nothing wrong in writing it like this. Now, what is the use of writing it like this? That if you write it like this, when you do integration, you have written 5 sin x like this. Now, when you integrate, you divide this with this separately, you get 1 dx integration, and you divide this by this separately, It will be x plus 2 times. This, if you take as t, this numerator will be automatically dt because its derivative is in the numerator. That is why we have taken it. You can check also sin x derivative is cos x is minus sin x. So this will be log of mod. So the answer is, then you put t as sin x minus 2 cos x. Have you got it?
Yes. So how are we supposed to know that we have to do that step, the 5 sin x step?
No,